Hello students. So again I am here with taking my new session. Hope you would like my channel and you are liking my every videos and you are watching very well. So till the session we did 4 to 5 methods of complex variable, and in this session I'm again going to start one more new method with the part 1 only. So again we are doing all the chapters of part 1 only, all the topics. So here you can see that there is given one more method in front of you, and the name of the method is the logarithm of a complex number. It means now whenever in the question it will be like of logarithmic functions. Okay, so at that time what you have to apply, what are the rules and formulas for the logarithmic functions. So in this one you have to do here, first of all I have written one notes for that. See guys, before starting every methods I will put one important note of that particular method, and that will be very much useful throughout the semester. So please don't forget to do these notes, because if you will get these notes then definitely you can easily understand all the concepts of the examples. So starting with the notes guys, and here I've written if z equals to, I'm just highlighting guys, 1 minute. Okay, now if z equals to x plus iy is a complex number, then its polar form is, okay, so we all having z equals to x plus iy, and this function I am converting into the polar form, and that you know very well now, because very first day we did this formula, and at that session we have used x equals to r cos and y equals to r sin theta. So in place of this we can apply z equals to r of cos theta plus I sin theta, yani ki r cis theta, right? Where x equals to r cos theta and y equals to r sin theta, where r equals to under root of x square plus y square, and the theta equals to tan inverse y upon x. So first of all you have to just writing this for your information, for the knowledge. Now you know very well that we have z equals to r of cos theta plus I sin theta, yani ki r cis theta. Okay, so in the method of root of complex number we have applied in the angle, like in place of angle we were putting 2n pi, right? And on that method we have applied 2k pi, but here I am applying 2n pi plus theta. So in place of theta I am adding one more component of 1 quadrat, yani ki 2n pi plus theta. Okay, so in place of theta I'll put now 2n pi plus theta, as well as here also I plus I sin 2n pi plus theta. I'm just applying whole quadrat. Okay, so that's why I have applied here 2n pi. So now it's actually your c theta, and this one we can denote it as e raised to I theta, if you know very well, because this one already we did in our first session of the basic concepts of complex variable. So that we can apply here r into the, 1 minute guys, I am highlighting this, r into the e raised to 2n pi plus theta plus I. So because this one is your c theta, and based on that we can apply e raised to I theta, and theta here it's we have written 2n pi plus theta. Okay, so now applying log on both the sides, so that you can get the term log z equals to log r plus, here there is a multiplication between these two functions. So by applying the logarithmic functions, it will be by taking the log, then it will be converted into the addition form. So log r plus log of e raised to 2n pi plus theta into the I. Okay, now what is z? That is x plus iy. So I have written here x plus iy. Okay, now log r as it is, plus here it's e, and also here there is nothing but it's e only into the base. See, I have marked here with the red highlighters. So that will be, then the log will be removed. So the remaining term will be I into the 2n pi plus theta. It means this one only. This one is a rule of logarithmic function, and this one you have studied in 12th standard. Okay. So I hope you might be aware of this function. So that's why you will get here I into the 2n pi plus theta. So this is known as the general logarithm of x plus iy. So this is known as the general formula of logarithmic functions, and it is denoted by capital L or G, yani ki log x plus iy. So that actual we can write log of x plus iy equals to log r. We already having the values of r, so I am putting there r equals to under root x square plus y square plus I 2n pi, here 2n pi as it is, plus theta. In place of theta, of course, we can apply this one, theta equals to tan inverse y upon x. So this formula is known as for the general solution of the logarithmic function. So this formula is very much important, and whenever the question will be in the form of that prove that this one, prove that करके suppose आपको कोई functions दिया होगा, right? So on that functions you will apply this formula, okay? Because maybe in the term of the proof it will be written of n terms, okay? So now if we put, I'm applying one more case in this equation in the general formula. So I'm applying the case like if we put n equals to 0, okay, now I'm putting n equals to 0, then this equation will be known as the principal logarithm, and this one is very much important because in mostly examples we are going to use this equation only. At that time if we will put n equals to 0, then at that time the new formulas which we will get, that is known as the principal logarithm of x plus iy, and it is denoted by log of x plus iy. So thus, so in this formula I am putting n equals to 0, then you will get definitely this one term because n will be 0, okay? So these both formula are very much important, guys. So there are two kind of formulas, one is general and the another one is the principal logarithm. So in mostly examples we are going to apply principal logarithm formulas only, and rest of the example in which we have to find or prove some kind of terms of n. At that time we will apply this general formula, यानी कि this one, okay? And अभी आप मैंने जो explain किया है, okay, that is I have written here only as a note, so you can see that here what I have written. Now next we are going to start the example, and here I have given first examples. So let's start with the examples now, and the question is prove that set of values of log I square is not the same as the set of values 2 into the log I. Okay, so here you can observe that we did two formulas beyond our theory, right? And there were the formulas like first one it was for the general formula, and the another it was for the principal values, yani ki principal logarithm. So from these both the formulas you can apply any formula as we have discussed in the theory, and mostly we will use principal logarithm only, okay? But here first examples have did with the general formula, and in place of this general formula you can use principal logarithm also. So there is no worries, guys. For your information only I have applied this one formula, yani ki general formula, okay? So let's start with the general formula, and you know very well that what is general formula, okay? Now see, LHS is given log of I square and the RHS is given 2 into the log I. The values of these both should not be in equal form, that you have to prove actually. So I'm just finding first part of log I square, guys I'm highlighting so that you can get See, first one part is log of I square and the another one will apply for 2 into the log I. Okay, so applying for the log I square, and you know the values of I square, that will be -1, so that will be log into the -1. Now in place of -1, because that will be actually your z, and z yani ki x plus iy, so you have to find the values of x as well as y. So the x will be -1 and y will be the 0 form, because you can compare it with x plus iy, so that you can get x as in -1 and y as in 0 form. So now applying general logarithm, so log as it is into bracket under root x squared plus y squared yani ki 1 plus 0, as we are getting y 0, plus I into the bracket 2n pi plus tan inverse 2n pi, this one is for the this one is coming from the rule, plus tan inverse y upon x, y yani ki 0 and x yani ki -1. So this one will be tan inverse 0, and 0 yani ki we can apply tan, I mean you have to check for the values of 0 in which function of tan it is coming 0, so it will be tan pi form, minus pi form. So I have written here minus pi because tan is odd function. So here I have written I into the, because here log 1 and log 1 will be 0. So I into 2n pi plus minus pi. So that will be 2n pi I minus pi. And another one is for the 2 into the log I. So that will be again 2 as it is. Here under root of log of just 1 minute guys, here there is one mistake. Here it is log of under root 1 plus 0. So यहाँ पे मैंने ये बाहर लिखा है, but please not that. Okay, now here log of under root 1 plus 0 plus I 2n pi plus tan inverse y upon x, y here it will be the y 1 and the x will be 0. So y upon x यानी कि 1 upon 0, and 1 upon 0 यानी कि infinite, and you have to find the values of infinite for the function tan, so that will be tan pi by 2. So at the last the angle will be pi by 2. So at last you will get here I into bracket 4n plus 1 into the pi, and you can observe that the values of these both the functions is not same, is not similar. Okay, so hence we can prove that these both are not similar. And again I am repeating guys, you can use any formulas, but as a first one we prefer only principal logarithm only, right? And it's actually not compulsory, you can use this one also, but in every example we will mostly use principal. But here I have written first example by using general formula also, and as well as you can do it for principal logarithm also. And again repeating here, there is one mistake I'm highlighting with the red mark so that you can get that. Here it's not coming this bracket. Okay, this one is log of under root 1 plus 0. So please, I'm just removing this bracket over here. यहाँ पे bracket नहीं आएगा guys. Here it will be log of under root 1 plus 0. Yes. So now moving forward for the second example. And here I have written the second example, that for the principal branch, show that log of I cube does not equals to log of 3 log I. Okay, again you have to prove, and here I have written for the principal branch, yani ki you have to apply principal logarithmic formula only, because here it's specified. Okay, so now here we will apply principal logarithm formula. So first we will do for LHS, and second part we will do for the RHS. I'm just highlighting this part. This one is part 1, we will do for this one, and this one will be your part 2. Okay, so applying for the part 1, log of I cube, and you know the value of I cube, that will be, we can consider like I square into the I form, and I square yani ki -1, so it will be minus I. Hope you are getting, guys. Okay, now you have to compare it with the x plus iy, right? So comparing with x plus iy, the value of x will be 0 and the y will be -1. So here I am writing log of under root x square plus y square यानी कि 0 plus 1 plus I tan inverse y upon x, y यानी कि -1. So -1 upon 0. So at the last you will get the answer minus pi by 2 into the I, and this one I am saying equation number 1, as well as we will do for the RHS, and this is actual given 3 into the log I here. Okay, so now 3 into log I, and in place of I, the I you will consider it with the x plus iy, so that you can get x equals to 0 and the y equals to 1. So again applying the principal logarithmic formula, and you will get this one term, that 3 pi by 2 into the I. And from the equation number 1 and 2, this is your equation number 2, and I think I forgot to write. So this is your equation number 2. Yes. Okay. So you can see that from this both equations the answer is not coming same. Here you are getting minus pi by 2 into I, and here you are getting 3 pi by 2 into I. So of course this one is disproved. Okay, now third one is given, prove that I raised to I equals to e raised to minus of 4n plus 1 into the pi by 2. Okay, so first of all you can observe here, there is given that you have to show that, so you have to prove here, and you can see the term in the what is given to prove, and it is given e raised to minus 4n plus 1. Here it's coming n, and n yani ki we will use here general formula. Okay guys, at this time whenever the questions will be into the uh, uh, proof form, then you have to apply its general formula. If either it is given into the n form, then only then. So first of all, taking logarithm, general log yani ki logarithm on both the sides. Why? Because here it is given I raised to I form, and I just want to remove this I from the powers. So we are converting into the normal form, because we all having a formula that normal form like log I or log x, log z, etc. So I'm just converting into the normal form. So it will be applying logarithm on both these sides, so that you will get log of I raised to I equals to, and here it will be I that will be move on the right hand side. So I log I. Now log I यानी कि this is log z. So I को compare करना है with the z, and z यानी कि x plus iy. So compare it with x plus iy, so that you can get x equals to 0 and y equals to 1. So applying this formula, and as I said here, it's given in the proof of in terms of n. So of course you will apply general formula. So here we will include 2n pi plus tan inverse pi upon x. So here I will just simplify the term, and same then after I'm just taking the LCM, and here again removing I, so that you will get this I raised to I form e raised to minus 4n plus 1 pi by 2. And this example is very important guys, so I'm just highlighting this one is important guys. So in today's lecture we did 3 examples based on the logarithmic of the complex variable, and still there are so many examples, because here we just started today, right? So more examples we will do in our next session. That I hope you will do all the practice of these all examples, and now we will meet in our next session. Thank you.